सर आप लाइव है, you can start.
Okay. Yeah, good morning, dear participants. Welcome to the first live session of the course Supply Chain Digitization. We have all three faculty with us, Professor Priyanka, Verma, Professor Sushmita, Narayana, and myself. So please type your questions in the chat box. We'd be happy to answer those. So only thing, if you could kindly mention the week number or the faculty name along with the question, that will be great. Then we can easily find out whom you are addressing the question to. Yeah, Professor Priyanka Verma ma'am, Professor Sushmita, can you just introduce yourself also quickly once?
Yeah. Hi everyone, this is Sushmita from IIM Mumbai, and welcome to the live interactive session. You can type your queries in the chat box. As Professor Debabrata has shared, it would be useful if you can mention to whom you are asking the query, because there are three faculty in this course. Which faculty and which session or week, it would be useful to know. Else we can always look at the questions in the chat box and figure it out also. I think we have some questions also, but Priyanka can introduce herself and then we can start looking at the questions also.
Good morning, participants. We are looking forward to the connections, and we hope that we will be able to answer your queries, and we are quite excited to connect with you. I'm Professor Priyanka Verma. I'm from IIM Mumbai, and happy to connect with you in this live session. Yeah, thank you.
Yes, we have got our first question by Piyush Bhatia. So you are asking question related to data envelopment analysis. Okay, so for example, the scaling of input and output parameters. Is there any impact on result because of scaling of input and output parameters? For example, in used case study, if cycle time is being considered in seconds instead of minutes, then what would happen? Yes, it will have an impact. So that is why we usually normalize the value of input parameters as well as output parameters. But in this case, there was no need of normalization. So that's why I have not done it. But it's better to normalize. Otherwise, that specific parameter will have more impact in or more influence in the decision. Piyush, I hope it is clear.
Good morning, everyone. Yes, I think Piyush has said it's clear.
Okay, thanks, Piyush.
We have the next question about demand lumpiness from Vidit. How to handle demand lumpiness? So we can when we refer to demand lumpiness with it is all about like the demand is having a lot of variations, and that is we can say that it is not a consistent behavior from the demand observation, right? So one way is that observe the pattern of demand, and if there are outliers, try to understand the reasons of the outliers, and if there is huge variation in the demand observation, then obviously you have to find out a better way of doing that, because the higher is the variation in the demand pattern, it becomes more difficult for forecasting that data. So having a proper trend or seasonality, if we can find out from that data will definitely help. So taking out average of it in some way will be useful.
We have one question for week 10. That would be my week for the session, if I'm not mistaken. And the question is on what is the role of supply chain digitization in agri sector. This is a very good question. It's very relevant for the sector, especially in India. So digitization is going to have a lot of impact on the efficiency of the supply chain in agri sector. Whether it is in capturing data with respect to what is the kind of demand we have for the products, or also with respect to the data that we have with respect to the weather and soil and humidity conditions. This kind of information needs to be available in a real-time basis for the farmers, for the supply chain players, warehouses, any food processing sectors. So this kind of information is required in real-time basis. Here digitization plays an important role in capturing the data through the use of instruments, through the use of track and trace systems, and also through the use of information systems, where all the data pertaining to these activities can be visible to all players. Once this is going to happen, then the role of forecasting becomes much easier, whether it is in terms of forecasting the climatic conditions or the demand of various stages, as well as the understanding the availability of facilities. So good amount of visibility can be created through the role of information systems and control towers, which can provide that visibility. This is from the information systems perspective. Apart from that, we do require technology for helping us in managing the crops in agri sector. We are having a huge amount of interest being shown for the use of drones for spraying the fertilizers, pesticides, instead of too much of human intervention. We have seen the growth of electric vehicles when it comes to transportation nowadays. It is being experimented in warehousing to a large extent, as well as in last mile deliveries. Perhaps not so much in the upstream parts of the value chain. There we have a lot of technologies which are being used in terms of the tractor technologies as well, that are helping out the farming of the products. So we see huge amount of role of digitization when it comes to end-to-end mapping of the supply chain. E-commerce also plays a huge role. We are having a lot of players who are entering into the farm supply chain, who are trying to connect the vendors as well as farmers to the end markets without the role of too many intermediaries, so as to provide the correct visibility of prices as well as demand to the farmers. So this is the era of e-commerce, where all of these possibilities are there, and agri sector can really benefit from these aspects. So I hope this gives a broad understanding. This was asked for week number 10. I hope it was useful. We can move on to the other questions.
Yeah, so the next question again by Piyush Bhatia. So he is asking how operations research is different from analytics. So if you remember our discussion on analytics, the introduction slide, there are 4 major type of analytics: descriptive, diagnostic, predictive, and prescriptive. So operation research mainly falls under prescriptive analytics. So I hope you got the answer. Use. Yes. Then there are some questions related to the final exam. So Bharti ma'am and our TAs are trying to answer those. So please don't miss any of these assignments. Okay. Then we can move to the next question. Okay. so next question is related to how does the scaling for biologic matrix is done. Yeah, Professor Sushmita is by Sam Kumar. The question is by Sam.
Yes, I can see that. Thank you. Yeah, Shyam Kumar, I think we have also shared the supplementary slides for answering that query. What I will do is maybe I will share my screen to show you what we were, what has been shared in the class. I mean, with the class. These are the supplementary slides. There were a few queries with respect to how the scaling was done for distance and all of that. Let me just share my slides and take you through that part. So this is, I hope my screen is visible.
It is.
Yeah, so in the previous, in the Kraljic metric example, we had taken this example of products. So I'm just going up to the example itself, where we had taken 8 types of products with their purchase value and the profit which was scaled, the number of suppliers. The number of suppliers also was scaled and the distance was also scaled. Then we have given weightages to the scaled values and then computed, what is the supply risk or what is the profit impact, as on and so forth. So in the next couple of slides, maybe I'll just take you through that. So for example, if I were to consider the, for the supply risk, okay. So supply risk was related to the number of suppliers. This was primarily the amount of suppliers being more would indicate that we have low supply risk. So for that, what I did was I have taken the number of suppliers and the highest number of suppliers will be assigned the lowest value on a scale of 1 to 10. Okay. So that if the number of suppliers is maximum, that will be given a value of 1. And the number of suppliers is very few, then it is given a value of 10, which means it is high risk. So higher the value over here indicates higher risk. And then using these two as a reference point, the remaining data is scaled linearly between these two values using a line equation. So I have shared an Excel sheet also. I can maybe show you briefly what that looks like. So just to give you an idea what the values would look like, we have the, on this side I can show you, we have the number of suppliers plotted on the y-axis for each of the items. 1, 2, 3, 4, 5, 6, 7, 8. 8 items, the number of suppliers. As you can see, the printer ink cartridge, it had the maximum number of suppliers. So it has the least risk. Okay. And over here, the printer ink cartridge A and B and syrup. These had the least number of suppliers, perhaps 1 or 2 or so. And they have been given the highest value of risk, that is 10. Now, as you can see, in between it is linearly scaled based upon how many suppliers were actually available. So over here I have used a scale of 1 to 10 and plotted it linearly. So the equations for that are there in the Excel sheet. I will also show that to you. Now in the similar way, if I were to consider the supply risk contributed by average distance of the supplier, what I am considering is if the supplier is very far from the bottling plant, then the risk contributed by that particular supplier for that product is very high. So again, in the same way, here if the distance is very high, then the value of risk is assigned as 10, that is high risk. This is different from the number of suppliers. In the case of number of suppliers, if the number of suppliers was very high, we considered that the supply risk is actually low. Here it is the opposite. If the distance is very high, we are considering that the supply risk is actually going to be high as well. So it moves along with the distance from the bottling plant. And if the distance is very low, it is assigned a low risk. So if you see over here, I have again the 8 items over here. And plastic bottle is actually very close to the bottling plant. It has been assigned a low value of risk. and the syrup is very far from the bottling plant, it has been assigned a high value of risk. In a similar way, I have used linear scaling on a scale of 1 to 10. So all of the, I take the highest value and the lowest value and plot all the remaining items between these two values. I'll again show that in the Excel sheet. And then we have the profit impact. For profit impact, I have taken a scale of 0 to 10. You can take scale of 1 to 10 also. That's not an issue. I have taken over here as 0 to 10. So if the purchase value is very low, we are considering that as least profit impact and it is assigned a scale of value of 0. Purchase value is very high, it is assigned a value of 10, which is highest impact over here. So in a similar way, you can see how they are plotted over here. Now what I'll do is, I'll show you the Excel sheet. So this is, let us say I'm looking at the number of suppliers. As you can see, the number of suppliers is the highest for printer ink over here, printer ink cartridge. Let me zoom out a bit. Yeah, number of suppliers is highest for printer ink. So I have taken number of suppliers as the highest value will represent the least value of risk. So 2000 will be assigned a value of 1, which is least value of risk. And the number of suppliers being 1 will be assigned the value of 10. So using these two, what I do is I try to plot a line between these two numbers, where on the x-axis I am going to have number of suppliers, and on the y-axis I am going to have the value of risk, which is 1 to 10. So if I take this way, what I did is I am going to look at finding out what is going to be the slope of a line which is going to be having h15 minus h14, that is this one, h15 minus h14. Okay, so this one divided by the maximum value over here, which is 2000 minus 1. So using this I found out the slope of that line, and using this I found out what will be the intercept of this line. Okay, so using the same kind of functionality. Now by doing this, what I then did was I just needed to plot the line based upon the number of suppliers. So over here I have here, I am going to consider h11 into h2. So what is h11? H11 is the slope. So m into x. What is x over here? 2000. So minus 0.004 into 2000 plus c. What is going to be c over here? h12, which is 10 over here. So this will now give me a value of 1, which is over here the low risk. Like I mentioned earlier, this will be assigned low risk. So low risk is assigned to 2000 and highest risk 10 is assigned to number of suppliers 1. Now suppose I have to pick any number in between over here. You can see over here I have found out the slope using this information. So over here h11 into 5, h5. So 500 into minus 0.004 plus 10.004. This is giving me a value of 7.75. So I have scaled it this way. So this is how I have done for number of suppliers. In the same way I have done for the bottling plant, distance from the bottling plant. And in the same way I have also done for the profit impact. Now once I have done the scaling on 1 to 10 for suppliers due to number of suppliers and suppliers due to distance of suppliers, I am applying a weightage of 0.8 and 0.2. 0.8 weightage is going to be given to the suppliers due to number of suppliers. 0.2 weightage is going to be given to suppliers due to distance from the bottling plant. And then I'll get a weighted supply risk over here. So this is the effective supply risk. In a similar way, I have done the profit impact scaling. I have done profit impact scaling on 0 to 10, not 1 to 10. But you can use 1 to 10 or 0 to 10 because you're just scaling it. It is just to basically plot it on the graph as such. You could use even the real value of the profit impact. That's not going to be an issue. So over here in the same way, the maximum profit is going to be assigned a value of 10. So that would be assigned to this particular value here, profit impact, as you can see here. The highest profit impact is related to the highest purchase value, and the lowest profit impact will be associated with the lowest purchase value. So I have given that kind of a scaling in a similar way, and I have got the value of the profit impact in a similar linear fashion. I have created that scaling. So this Excel sheet also we have shared. You can go through it once, and it will be helpful to you. I can understand this is slightly complex, but the idea of the Kraljic matrix discussion was to mainly tell you that you can do this kind of scaling, and you can plot them on the graph using these values. You could use different types of scaling. Like I have used 1 to 10, you can try out 1 to 5, or you can even try 1 to 100. It depends upon what scale you want to see on the graph. It is up to you. My main reason for scaling is because I wanted to give a supply risk rating for number of suppliers and a supply risk rating for number of a distance, and then combine the two to give a weighted value. So that was the main reason that I used scaling, because otherwise number of suppliers and distance, these are two different metrics altogether. So that is why I went ahead with scaling. Okay. So I hope this answers the query, and maybe we can move to the other questions also.
Yeah, I think there is one general question about admissions in IIM Mumbai, and this question is about whether this certification program will help in the admission. So yes, there definitely these type of programs will help you in building your knowledge about the supply chain and the way the digitization is going on, and the approaches related to analytics and how different problems in supply chain can be attempted through these type of analytical approaches. There are different modeling methods that has been covered in this course, starting from machine learning algorithms, optimization methods, MCDM approaches, and descriptive analytics, and many more. So almost this course has covered a gist of all the possible way of analyzing data in the supply chain domain. And there are several other domain of supply chains which has been covered through this course. So I'm sure that the way this course has covered the length and breadth of analytics and its application in supply chain domain will definitely help the participants to understand the way the supply chain needs to be managed. But in terms of admissions, obviously there are certain eligibility criteria of the institute and for each program. So I'll request you all to please follow that, and based on that, please attempt for it. And we'll be very happy to see you all here taking admission into any of our program. The second question which I have received is about the break-even analysis, and the question is about that while calculating the break-even point in the graph, we have shown the sales revenue. So maybe let me just share my screen. 1 minute. Yeah, just let me know whether the screen is visible. Yeah, is the screen visible?
Yes, yes.
Okay, so we can see that if we look into this graph of break-even analysis, on the x-axis we have kept the volume, and on the y-axis we have kept the revenue cost, and the intersection of the total cost and the sales revenue is considered as the break-even point. Now, while calculating the break-even point, the formula that we have used is fixed cost divided by the revenue per unit minus variable cost per unit. So there is a doubt about that why sales revenue is not coming in this formula. Please remember that because we have to calculate the break-even point value, we are dividing the total fixed cost divided by the per unit revenue of the product with its difference with the variable cost. So that will help us. Okay, this becomes the break even point, or the point at which there is no profit or there is no loss. So the sales revenue is calculated as the revenue per unit into the total volume for every stage of the volume. But while calculating the break even point, this has to be the per unit value of the revenue. So please don't get confused with these two things. They both are calculated from each other. Okay. I hope I have solved this query. Yeah, thank you.
Okay, then there is one question from Sangamesser IR. He is asking question related to random forest. So, like understanding issue of random forest. So let me share my screen quickly. Enter screen. So although we have discussed in detail in the class, but still I'll once again repeat what we have talked about. So random forest, basically one algorithm like in which multiple decision tree are built. So that's where the name forest has come. So if you let me use the yes. So that's where the name forest has come, because I have multiple trees in the forest. Okay. So if you see, the first step is I have to draw k number of bootstrap sample from the data set. So bootstrap sample is nothing but sample with replacement. Suppose you have, let us say 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Suppose you have 10 observations with you. So now how can I create bootstrap sample from here? I will do sampling with replacement. Okay. So let us say first I picked, I got 2. Second time I again dropped that observation 2. I picked another sample, I got 4. Third time I got 5. Maybe I got 4 again. I got 6. I got 7. I got 7 again. I got 6. I got 2. I got 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I picked 10 observations again from this sample, but with replacement. Since it was with replacement, I got 4 twice, I got 7 twice, I got 2 twice, I got 6 twice, and 3 once. I have not got 1, 9 and 10 at all. So my new sample which I am getting here is 2, 4, 5, 6, 7 and 3. So every time you have to do this process. So this is called bootstrap sampling. So from the main data, if I have 10 observations, I will use this bootstrap sampling method and I will get one sample. Okay, this is the first bootstrap sample. Then similar way, I will get another bootstrap sample. I will also get another bootstrap sample. I will also get another bootstrap sample. So I need to get k number of bootstrap sample. So now if we look at it, since this process is randomized, every time I will get different sample. Maybe few observations will be common, but not all will be common because the process is randomized. So I am getting sample 1, I am getting sample 2 and so on. So I am getting sample k. Okay. So I have got k different samples from this set of observations, and in each sample the observations will be different. There will be few which will be same, but not all will be same. So what I am doing, I am randomizing my sample. So if you see this is entry, first this is entry T1, I will have sample 1. In this is entry T2, I will have different sample. This is entry Tk, I will have different sample. So it's coming from this same parent set of observations, but the observations will be different. So first we are randomizing the sample, and then second we are also randomizing the features. Suppose I have 4 independent variables, so every time the features will be randomized. So I will get two different features here. I will again randomize, I will get two different features here. So of course, since number of features are 4, I will get one feature may be common. So if you have multiple features, let us say 9, 16, lot of features, then if you do randomization, so every disease entry you will have different set of features and I will have different sample. So what I am creating, I am randomizing the process. My sample is different, my features are different, and I am creating a disease entry. So let us say this disease entry suggests the value of the dependent variable is y1. The second disease entry, let us say it predicts the value of the dependent variable is y2. So I will have k number of disease entry. Each disease entry will predict the value of the dependent variable. So I am getting y1 from disease entry 1, I am getting y2 from disease entry 2, I am getting y3 from disease entry 3, I am getting yk from disease entry k. So since it is a regress entry, I will take the average of this k predicted value. So this will be my prediction. So instead of relying only one model, one disease entry, I am developing multiple trees and then taking the average of these predicted values. So my prediction will be much more robust, and in the test data it will perform in a better way. So if you see that this simple disease entry, it has only one model and it is not developing multiple models. So therefore many a time it faces the problem of overfitting. So therefore, to avoid overfitting concept, we develop multiple trees, we get multiple prediction and take the average of this predicted value, and that is how we get the average predicted value, which is my prediction, and this will be much more robust compared to simple decision tree. So I am sure you got the idea. So if you have still doubt, please let us know in the chat box. We will be able to, we will try to answer your queries.
Okay. I think we have some questions. We have some questions related to the textbooks that requires to be followed, and also about some reading material. So all the faculty members have shared their slides and the Excel sheets that they have used during the session. It has been shared with the participants. We request the participants to please look into that. Along with this, if you visit our course website, there we have mentioned about the source textbooks which can be used. So one of the very famous textbook that we probably have mentioned is about Chopra and Mendel, Supply Chain by Chopra and Mendel, and also a similar book by Professor Simchi Devi. These are the two prominent textbooks which are generally being followed in the area of supply chain and analytics. Over and above, you can explore many books related to analytics in this field. So that is one request to all of you. And we also request you to please follow the sessions that have been covered, the slides that have been shared, and also the Excel sheet that has been given to you for your practice purpose as well. So please do more practice with the Excel sheets. That will definitely help you in understanding all the steps and processes. Another query that we have received is about picking up the Python for doing the different models that has been covered. Even we have shared the Python codes also for your analysis part. With respect to Python, we understand that those who are not having a coding background will find it little difficult. But in today's time, let me assure you that doing the programming is not so tough. If you just spend some time by learning the basics of it, you will definitely find it easy, and it's the right time to pick up this skill, because going forward, analytics is going to be the future for all of us. So Python is not so tough for all of us, and just spending some time will definitely help you for this.
Yes, so just to add what Professor Priyanka ma'am has suggested, so we have already shared all the codes as well as data set in CSV file, and we have also demonstrated how to use Google Colab. So So please practice it once and look at the video again and again, and I am sure you will be able to generate the similar output. But as ma'am suggested, it needs practice and nothing to worry. The main important thing is the concept. So I am sure which you have understood. The coding skill will come if you practice more. Yeah, thank you.
Yeah, I am just following up on the Kraljic matrix itself, just few responses maybe. Shyam has asked for the Excel sheet to be shared. So we have shared the supplementary slides as well as Excel sheet with the NPTEL team. I think they would have uploaded it. You can have a look. So the slides which I showed you just now as well as the Excel, it is there in your content. It will be available. Then another question that why we are using the slope intercept form for scaling. It is for linearly scaling the values of risk for the number of suppliers or for the distance or for the profit impact. You can use non-linear scaling methods also, but for simplicity's sake, I have taken linear scaling approach over here. You can try out different approaches, but I would say when you're starting off with frameworks like Kraljic and all, start off with linear scaling, and then you can go to more advanced methods of scaling. Just one query which was there with respect to push and pull for the supply chain. I think this is from Piyush. How to decide push and pull method to define the inventory at different stages of the supply chain. So this is an interesting question. So push and pull is related to the nature of the product and particularly the nature of demand. Push is mostly the part of the supply chain which is more efficient in nature. So those parts of the demand which are extremely predictable, we are going to assign that part of the demand to the push stage of the supply chain. And those parts of the demand which are slightly unpredictable, for example, what color of sweater which is going to be purchased, or what color of paint, or what kind of the product configuration is going to be finally purchased for the laptop or the mobile, that is assigned to the pull part of the supply chain. So many a times you will see that more or less a lot of the inventory in the first part of the supply chain will be managed in a lean fashion, because that part of the demand is aggregated across different types of variants and all, and it is very well known. It is highly deterministic in nature. You can use proper forecasting methods. That part of the demand which is more uncertain, we assign that to the pull part of the supply chain, which comes later in the supply chain. And I think more on this, I guess, was covered by Professor Priyanka, so maybe she would like to add on that.
Yeah, so it is in continuation to the same what Professor Sushmita has already covered. So when you talk about deciding the push and pull concepts in supply chain, it's very important to decide about the push and pull boundary, where it should be located. And as she mentioned, it is related to the type of product and the demand, the uncertainty related to the demand. So higher is the certainty associated with the product demand and the nature of the demand. You can understand that that type of product is required to be closer to the customer, and that's what we can say, that we should carry more inventory of such products near to the customer. So in terms of deciding the push and pull boundary, it should be located more closer to the customer. So higher is the uncertainty, so that you can manage those uncertainties by keeping the inventory near to the customer side. Whereas if the demands are stable and it is like the uncertainty is not very much, the product nature is also stable. So in that case, this push and pull boundary can be brought closer to the manufacturing site. So that means that the inventories can be kept more at the manufacturer or at the warehouse and so on. So remember that where you should keep products and what should be the quantity of that products totally depends upon your strategy for deciding the push and pull boundary, and this is influenced by the nature of the demand, nature of the product, and so on. So we have covered this about demand uncertainty in the initial sessions. Maybe you can have a close look into that once again, and bring those characteristics while deciding the inventory in your or while deciding about the location of the inventory, depending upon those characteristics, by looking into the push and pull boundary as a solution.
Yes. So the next question is related to, I think there are some questions in the Excel file which students have uploaded it. So how do you decide which algorithm to select? So it's an interesting question. Like depending upon the context, this will change. So let me share the screen 1 second. So it was already discussed in the class, but I'll mention it once again. Okay. So how do you select the best forecasting model? So first I have to understand the data. Okay. So depending upon the pattern in the data, I have to find out which model would be preferable. If there is a seasonality in the data, if there is a lot of randomness, no seasonality, if there is a cyclic pattern in the data. So all of this you have to observe carefully, and accordingly the model will be selected. Then also we need to choose evaluation matrix. So there are multiple evaluation metrics which you can see here. Like I have mean square error. In our example, I have used mean square error. Then there are mean absolute deviation, mean absolute percentage error, bias, tracking signal. So these are the various measures of forecasting error. So depending upon your data, depending upon your business, you need to decide which error should I select. In our case, we have selected MAC. Suppose you select MAC as your evaluation matrix, then you need to stick to that, and then I need to split the data in training, testing and validation, and then I will experiment with various algorithms, and we'll see in the test data. Since I am using the training data to develop the model, I will not measure the performance of the model for training data. I have to see the test data, and usually we take 30 to 40% of the data as a test data. We reserve it as a test data. Then once the model is developed, different types of algorithm will check and see their performance on the test data. And on the test data, since in our case we assumed MAC, if MAC is low, so that model will be selected. Suppose I have model 1, model 2, model 3, and MAC is lowest in model 2 in the test data. Then I will select model 2 as my forecasting model, and I will go ahead with this. And also I need to fine tune the hyperparameters. In decision tree, I need to fine tune the depth of the decision tree. In random forest, I have to find out how much depth should be there in decision tree, and also how many trees should I have in the forest. So depending upon your algorithm, there will be various types of hyperparameters which you need to tune it and get the optimum value of the hyperparameters. So that is also a process. Once I use optimum value of hyperparameters, then I will develop the model using the training data, and I will test it on the test data. And on the test data, if MAC is low, let us say for model 2, that model will be selected. Then there are some further requirements. I have to also consider the interpretability. Suppose I develop a very complex algorithm, and the team member who will be using this model is not so well versed with the technicality. So therefore I cannot use this model. I have to, depending upon the audience, depending upon the team member who will be using this model, I have to make sure that model is easy to interpret and model is easy to use. Otherwise, user will not be happy with the model. So I have to also consider interpretability. Then there is a issue called resource constant. Suppose I developed a very advanced model, but it requires cloud computing, it requires investment in huge technology. So therefore, I may not go with that. So depending upon how much budget you have, how much money or resource you would like to spend on that model, you have to take a decision. So it's not always MSc. There are multiple factors which you need to decide, and you need to select the best forecasting model. So this is again like once you keep on practicing it, you will get more ideas and you will get a lot of hands-on about it, and accordingly you will get the expertise. But slowly you will develop this expertise. So thank you. And then I think there are a few more questions.
Yeah, I can see there is one more question on BEP analysis. And the confusion is that when the analysis is done and the graph is plotted, then why the fixed cost and variable costs are considered and not the sales revenue for calculating BEP. Please note that the sales revenue has been calculated by multiplying revenue per unit into the volume of the product. So this gives you the total sales revenue, right? So if you expand the formula, the sales revenue is equals to revenue per unit into the volume. So, and similarly, when we have to calculate the break-even point, that's why we have to divide by this fixed cost divided by the revenue per unit minus the variable cost per unit. So that's why please do not get confused that why sales revenue is not coming into the equation of final equation of break-even point. It is there, but instead of taking the total value of the sales revenue, we are considering revenue per unit into the formula as the we are looking for the that volume of the analysis at which the total cost and the sales revenue matches each other.
Yeah, thanks. Thank you. Next question is related to MSc. Some learners have shared this question in the discussion forum as well. So I'll just share my screen so that it becomes more clear. So many of the students are asking questions related to this, like how MSc has been calculated, like how are you getting 1637669. So there is one rounding of issue. So I have not shown the exact value. It is not 2270, it is rounded up value. So I'll share the Excel. I think then you will get more clarity. So this is the actual value. I think you can see my screen, Excel file. Ashish, can you see the Excel file? Yes. So if you see this data, the average value is not 2270, it is 2269.7143. So if I take the average order quantity, let us say column M, then the value is coming out to be 2269.7143. Since in the PPT I have rounded up and shown to you, you are treating it as a 2270. That's why your calculations are not matching. So I suggest that take the actual average, and then I will also upload this file in the folder so that you can reproduce the same result. So this is my average value. So how MSc is calculated? I have to divide like 990 minus 2269.7143 square. So if you see this 990 minus 2269.7143 square. So that is how I am getting the squared error. Then if I sum up all of this squared error, it will be this value, and then I have to take the average. So average of all of this squared error is nothing but mean square error. So mean average square error means the square error. So that is how this is calculated. So I think there is a confusion because of this value, since I rounded it up, and because in the PPT there is not much space. If I round it up, it is coming out 2270, but actually is 2269.7143. So please calculate this. I am sure your answer will match with my answer.
Yeah. There are a lot of questions related to exams and the pattern of the question paper. If NPTEL team can help us in this. I think they're answering the queries. We request the participants to please look into this. Also, there is one question related to push and pull boundary and how it is related to inventory. See, the push and pull, as it's already explained, push is related to the efficient supply chain and pull is more related to the responsive supply chain. So, how do you want to keep your supply chain? Is it like what part of the supply chain is required to be efficient in nature? Efficient, we already have discussed, means things are running in a very simple language, in a very, very simple way. Things are all systematic, everything is running in an order. Whereas responsive is like you want to apply all your resources, but you just want to complete that demand instantly. So, how you will work for that part? And remember, when we are trying to complete the things in an instant manner, we apply all our energy in doing that part. So, here you can correlate this with keeping the inventory also. That is one of the solution for being responsive, that when we want to ensure that we want to complete the demand of the customer in an instant manner, we should carry more inventory. So the point at which, or the way you want to keep your supply chain, by making up some part of it following the push nature and the other part of it following a pull nature, we can say that the intersection of these two strategies, at this point you should keep your inventory in a larger quantity, so that you can take the benefit of both push and pull in one go, ensuring that the demand of the customers are getting satisfied.
All right, there are some questions related to, okay, so there are more questions related to AHP and BEP. Perhaps that can be taken up. Otherwise, we also have questions in our supplementary sheet. You can check that as well. Maybe I'll just pick up one question from the responses sheet that we also got. There are a few other, which we received offline queries. So one question that we have received from Mr. Vikash Kumar is what strategies should firms implement to effectively manage the transition to a digitized supply chain? This is a very interesting application oriented question. So thank you for that. The first and foremost aspect before you can move to a digitized supply chain is to see whether your processes are actually ready for digitization. So the first step would be to see whether your records are in the form of any kind of digital kind of content. Let's say you're talking about the records related to your inventory or to your sales. It should not be present in the form of hard copies. It should be present in the form of Excel sheets at the very minimum. This is the first step. Now, once you have this kind of data which is present, then you can start looking at analyzing this data and seeing what is going to be the best way to do the next steps of maybe production or transportation. Now, the other aspects when it comes to digitization is this is a very basic level of digitization, right? But suppose we are talking about you're already using Excel sheets, you're already having this kind of analysis. The next step would be to see whether all the players within the supply chain are also using these kinds of information systems. So that is where, there was this lecture on ERP systems, which was held in week 10. And you can maybe refer to that as to how it is important for variety of players within the supply chain to have ERP systems also developed such that they can talk to each other through electronic means. So this is a very important requirement for moving towards digitization. The very first requirement would be to start off by maintaining digital records and virtual records. The next step would be to look at information systems such that the various supply chain players are talking to each other. This is one of the basic steps that needs to be carried out. Now again, coming to capturing the information which has to be kept in these records, we should not be looking at doing a lot of manual data entry also into the Excel sheets. So that is where we have the track and trace systems, which also has been discussed in one of the lectures, as how this can automate the capture of data from variety of processes, whether it is the product count or whether you're talking about finding out the temperature and weather conditions of the storage, and capturing this information at the point of sale or capturing this information during transportation. This can be done in an automated fashion. So this is, I would say, one of the most popular technologies that has come in, which can help in removing the efforts required in data capture. So these are some of the basic steps that are required for creating those records. Now this is part of creating the information systems. But on the other hand, you also have, nowadays it is becoming impossible for a company to survive without a virtual presence on e-commerce. So you need to see which kind of e-commerce or e-marketplace you are actually going to fit into. Whether you are more viable to fit into an e-commerce marketplace which has direct reach to end customers, or should you be on an e-commerce marketplace which has reach to other supply chain players also, maybe other traders, other manufacturers. So you have to figure out in which kind of e-commerce system you need to be working. So this is one part. The other aspect is of fintech, which is bringing in more digitized form of payments and all of that, which I'm sure will be covered in some of the upcoming sessions as well when it comes to blockchain and all of that. But we are also having this particular aspect, which is very common nowadays. So these are some of the ways in which companies can move slowly, but you can actually move quite quickly because the capabilities of people are also improving at the same pace as well. We are seeing that kind of skill sets that people are having, and you can move quite easily to a digitized form of supply chains. So almost every supply chain nowadays, we see some level of digitization will be present. Some of the supply chain players will be more sophisticated in their applications than the others, but we do see some amount of digitization which is present. So I hope I have answered Vikash's question. He is, I think, not on this session, but he has definitely sent his query yesterday. Yeah, we can go on to the next question.
Okay, I think there is some one more question Bhavya Sharma has asked related to break-even point again, and also related to AHP normalization. Let me share my screen, and maybe we can try to answer that once again. 1 minute. So just confirm that this is visible. The slides are visible?
Yes.
Okay. Okay. So remember this break-even analysis, what we have done, and when we are talking about break-even point, how we get this break-even point, let me try to make it once again. The total cost, as we all understand, 1 minute. The total cost is calculated as, it has got two components. One is,
So you are not in slideshow mode in the.
is it not visible?
The slide is visible, but not in slideshow mode.
Okay. Is it okay now?
No, no, it's not coming. You
No,
share the full screen and then make F5, na?
Okay.
And then if you write, then it will be written. Otherwise, digital pen will not work. If you write, na,
Okay.
on a normal PPT, yes.
Yeah. Please let me know whether it is visible now.
Yes, yes, it's visible. Now you can write, yes.
Okay. Okay. So I'm just going through the break-even analysis once again. And here, if you remember, the break-even point for calculating that, we have got two components. One is total cost and the other one is the revenue cost. So how do we, the sales revenue. So how do we calculate total cost? Total cost again has got two components. One is the fixed cost and the second one is how much revenue you are earning for it. So if it is, let's say, if the revenue cost is R and let's say the X is the quantity corresponding to that, the total cost is getting calculated. So this X is very important. We are going to find out the value of this X. So in this way, we can calculate the total cost, which is a component of fixed cost and the revenue cost. Whereas the other cost is your the other cost is your sales revenue, and the sales revenue you can say that the sorry. So this is the variable cost. I'm sorry for the mistake. This is the variable cost for per unit how much we are incurring for making that product. So this gives you the total cost, which is a combination of fixed cost and the variable cost per unit into the quantity, that is X. The next cost is the sales revenue, and which is given as very simply revenue per unit into the quantity X. So if we say the break-even point is the point at which the total cost is equals to the sales revenue. So if I write this to both the formulas over here, which becomes fixed cost plus variable cost into the quantity is equals to the sales revenue, which is the revenue per unit into the quantity X. So remember, we are trying to find out that break-even point, and that break-even point is given by X. So how do we get this value of X? If I just do some shifting over here and there, right? So in doing that process, we can find out the value of X from this little shifting, and the X or the break-even point, we can see that is coming as the the fixed cost divided by the revenue that you are earning minus the variable cost, right? So here the same formula we have shown you in this dialog box also, which is given as break-even point, which is a unit. You are looking for that volume of the product at which your total cost that you're incurring matches with your the total revenue. So at that point you have this is a very famous notion that is always referred in the business environment, that we always ask, what is your break-even? So that is the point where which the total cost that you are incurring becomes equal to the total sales revenue. So that's why the sales, the break-even point is one of the important aspects that is can be calculated using this formula. The same we have shown in the form of this formula over here. Okay. The second, I think the comment was related to AHP. So let me share my screen once again related to the AHP. Just confirm that the Excel sheet is visible. Yeah, you can see the Excel sheet.
Yes, ma'am. Yes, you can see.
Okay, thank you. So the question was that we have considered different factors and why the normalization of these factors are done and how. Remember that when we are doing a AHP analysis, we are trying to compare the different elements or different, here in this example we have compared the SKUs, and the criteria which have been considered for comparisons are of different nature. Some, like in this example, the Excel sheet we have already shared with you. If you see, we have got different factors like monthly demand, like the priority of the product, average supplier's reliability, profit margin, lead time, and the likelihood of return. If you look into the unit of these factors, they all are different. Like demand has got the unit of units per month. The priority of the product has got a score which is in the range of 1 to 10. Then similarly, we have the supplier's reliability, which is again explained in percentage. Profit margin is in percentage. Lead time is in hours. Likelihood of return is in percentage. So we can see that the unit of these factors are changing, right? So when we talk about comparison, they all need to be brought down in one scale so that the comparison can happen, and that's why there is a requirement of normalization, right? So that's why everything has been brought down on a scale of 0 to 1, so that if you can easily compare these factors, and based on that the relevant comparisons can be done between the SKU codes. So how this again, how we do the normalization? There, for normalization there are different ways, but here what we have done, we have found the minimum of the overall value which is given for that particular factor, as well as the maximum of that factor. So for example, if our criteria is demand, the minimum demand and the maximum demand has been considered. So here you have minimum demand and maximum demand. So let's say if I have the 30 SKU or 100 SKU, I'll find out the minimum demand and the maximum demand. And for normalization, let's say if I'm looking for the normalization of first SKU code, which monthly demand as 1366987, I will, in order to normalize it, I will, let's say the observation is taken as Q, which is equals to 1366987. So the normalized value of this will be Q minus minimum demand divided by maximum minus minimum. So when I applied this formula, you can see from the Excel sheet also. Now all the values have got converted between 0 to 1, and the comparisons within the SKU codes becomes easy. So now we can easily do the comparison with the help of these normalization steps. The same steps has been followed for all the other remaining criteria as well. I hope I answered the query of Ms. Sharma.
I think there are no questions further. So in the Excel sheet which they have uploaded, we have answered most of the questions. So one question is related to Python programming. So Python programming will not be asked in the end term, end module question. Like in the final exam, there will not be any questions from Python programming. It will not be tested. So Debabrata, I think if there are no more questions, then can we stop?
यस सर रवि सर ये
हाँ
रवि बोल रहा हूँ सर
हाँ जी रवि जी।
स्टॉप करूँ सर टाइम तो हो गया सर
हाँ जी टाइम भी हो गया, और कोई फर्दर क्वेश्चन आएंगे तो मैं फिर हम लोग नेक्स्ट सेशन में ले लेंगे। अभी तक तो हो गया क्लियर।
तो सर उनको बोल दीजिए सर कि
There is
फॉरम पे जो भी रहेंगे क्वेश्चन पूछ सकते हैं सर.
Okay, okay. हाँ, forum में. So if someone has missed live session, if you have further questions, please put those in the forum, discussion forum. Our TAs as well as ourselves also will try to answer those. Yes, Priyanka, anything else you wanted to add?
I think there is some question related to Excel solver. Mr. Vijay Kumar has asked that in the examination, can Excel solver will be provided or we have to calculate by manually? So I think that this will be more like what you are doing right now in the assignments, and in a similar pattern, the questions will be asked. So uh, I, I, I think for there it will require some basic calculations that can be done without Excel.
Yes, whatever calculator TCS will provide, same calculation is fine. You don't need to calculate like complex thing. So it's okay. You don't need to use Excel. You don't need to use any other.
So there's one last question maybe I'll pick up with respect to week 5. In probabilistic setting, this is by Bhavya Sharma. I hope I'm pronouncing correctly. In week 5 for the probabilistic setting, can you explain why we have added different probabilities? That is to represent that each kind of or each level of demand has a different probability of occurrence. It need not be always different. It could be same also. That would mean that every level of demand has equal chance of occurring. Instead of that, I have considered that sometimes higher level of demand has lower chance of occurring, lower level of demand has higher chance of occurring. This is more or less a very realistic case that we could expect to encounter in a scenario as such. So that is why I have used different probabilities for the demand. So I hope that answers the queries, and if anything else, we will be looking at the discussion forum as well to answer any other remaining concerns. Thank you everyone for participating in the session, the live session. I hope we were able to answer some of the questions, and I hope you have found the course useful as well. Thanks a lot.
Yeah, just last one remark. I would like to thank Sankumeshwar Ayerji. Thank you for responding to many of the questions in the forum and for your active participation. And we are also thankful to all the participants for joining our course, and we hope that this course is helping you in understanding the basics as well as the advanced components related to supply chain analytics. Hope to see you all soon in the future as well. Thank you.
Yeah, thank you. Looking forward to see you. And I think we should thank Bharti ma'am also. She has been answering a lot of queries related to questions, in-term pattern and so on. So thanks Bharti ma'am for your support throughout this course, and specifically in today's queries. Like you have answered many questions related to the technical aspect of exam as well as assignment. So thank you so much.
And thanks to our TAs and thanks to the NPTEL team for all the support.
Yes, they are the backbone. So, yeah, thank you to Sajji and your whole team, Debabrata and everybody. Yes, thank you. We'll try to have, let us say, one more session, live session, depending upon the availability of all the faculty. We'll inform you.
Thank you everyone. Have a nice day.
Yeah, thank you. Okay, so we'll then drop off.
Sure, I think we can drop off. NPTEL team can maybe confirm to us when we should conclude.
Yes ma'am, we are ready for stop.
Okay, thank you. We'll conclude. Thank you.
Thank you.
Okay, thank you.
Thank you.
Yes.
Thank you.